All right. Now we're going to do, this video is going to be algebraic methods mixed problems, but we're going to do page 62. Yep. Cool. So we already done page 61 on a separate thing. So here we are. Give an expression for the area A of the shaded figure below. Simplify and factorize your answer. So here it is. That's x there, that's x there, and that is y. Okay, cool. I've said this before. We have to cut this up into bits. If it's a shape, we see rectangles here, but you have to cut it up like that or something, so that we are working with this rectangle here and this rectangle here. You can also work out that rectangle there, that's x squared, and then take away whatever that would be. You'll get the same answer as long as you're using the right thing. So that would be, this square inside here would be x minus y times x minus y. So yeah, same thing. And we can do whichever one. I think on the one before, on page 61, I've added things together. This one, I think I'm gonna try to see if I can do the bigger gap and then minus that one. So that x squared is the entire square with that dotted line there, minus whatever this is, x minus y squared, right? Because that length there must be x minus y. Cool. Just expand it real quick. There we go. Yeah, make sure we get the signs right. Check those signs that that you're getting the same stuff. But anyway, after we simplify that out, it should be something like, there you go, and that's it. Moving on. 487. Give an expression for the area A of the shaded sector of the circle below, where r is the radius and s is the angle of the sector in degrees. The area of a circle is cool. All right, so that's the area of a circle. So if we put that in, that is the entire circle, right? Pi and then radius squared. There's the radius there. So this formula gives us the entire circle, but we don't want the entire circle. We only want that little segment there. That sector. Cool. Here, we don't even know what that angle is. We just know it's S. Here's how I would do it. I would multiply this whole thing by a percentage or a fraction or a decimal. Same thing really. So I'd use a decimal or a fraction, but what would that fraction be? It would be that angle there. Remember how a full circle is 360 degrees. And we're only working out what S is. So if we work out the entire area and then find out how much of a proportion that is, that angle there, we should be able to get it. So fractions work like this. I'm going to times this by S over 360. And that fraction there gives us a proportion to work with. That is the fraction or the percentage in decimals or fractions of that bit there. So there you have it. I actually wouldn't do anymore. I mean, I could just rewrite it so that it's neater. I mean, I would probably go S pi and then 360. I can rewrite it like that just so it's neater. That's the same thing, by the way, that line and this line. But there you have it. Moving on. B. Rewrite your answer in part A, which is cool, that one, with R as the subject. All right, let's move that along. Starting from this one, I'm going to times it by 360a, which is s pi squared. I'm going to divide both sides by s times pi, by s pi. So, 360a over s pi equals r squared. And just to get rid of that just to get rid of that squared there, and also I'm going to put r here, just to do two things at the same time. And there you go. Boom. Moving on. Mind you, I hope you've tried this again. Try this out yourself, and then watch this, follow along, write your own answers along with it. And on top of that, ask me any questions about any steps. If you don't know it, I'm not fully explaining. I'm not teaching you everything here. I am just moving along, just doing a little bit of commentary. Anyway, cool. 488. Give an expression for the area of the equilateral triangle below. Okay. We know that the area of a triangle is half, base times height, or width times height. I mean, whichever one you like. That height there, times that there, and then half that, is the area of a triangle. So we're saying if that was a square, just that size, a rectangle, quadrilateral of that size, it'd be half the area. Cool. We know the base if we work with that kind of shape, but we don't know what that would be. Yep, it's an equilateral triangle, so we know that's symmetrical. It goes right down the middle there, and we know that would be a right angle. Let's make that bigger. Right angle. All right. Now, also this part is actually, I'm just explaining. That would be half x. Cool. Knowing that, do we remember Pythagoras? Let's call this middle line here h, because we already called it h. Let's call it h. So h would be, well, h squared plus x over 2 squared, or half times x squared, the same thing, gives us x squared, this square. That's Pythagoras. If you remember, that's Pythagoras stuff, right? A, B, C being the hypotenuse. C squared is a squared plus b squared. That's just Pythagoras. Right. From there, we just work out what h would be. Oh, we don't work it out. We don't know the number. We just make an expression for it. So let's rearrange. Just minus that. And of course, h would be the square root of that. Square root of x. You know what? I'm going to just do this. You know what? Let's do that first. X squared. This bracket here, if I do square it, I get x squared on top, and then 2 squared on the bottom, which is 4. That's what I get. So if I do actually put them together, that minus that, remember they're like terms. Remember, this whole thing here is the same as that. It's the same thing, right? So if you're not quite sure why that's the case, we got to go back to how our fractions work. So multiplying by fractions, multiplying and using fractions. Have a look at that stuff, but I'm not going to explain it all here. but that's just the case. So that being said, it should be 3/4 x squared. I'm actually even going to just write it up here. Like that. Cool. And h being the square root of that. Done. Now we got h. Cool, we just put it in here. H is that. Remember, b is just x, because there you have it right there. So the equation is, so the area is half times, or let's not say times, let's just say x, and then square root, right, because that's our h. And there you have it. Moving on. I mean, I guess you could try to simplify that a little more, but I'm going to move on. Prove that equals that. Prove that this equals that. So if you want to prove it, what you can do is you start off with one side and then see if you can make the other side. So you start off with, you start off with that maybe, and then you rearrange, you do stuff so that you reach that thing there. So that would be a proof of that equation, and let's see if we can do it. Cool. Now, to do that, I would start with the more complicated, more bigger looking side, because then we would be sort of simplifying into this one. So let's start there. We call it the left-hand side. So we're saying the left-hand side is with that. Oops, that's not an x, that's a y. Let's do that subtraction first. So again, without explaining it too much, I should get x minus over xy. That'll be there over x minus y. Now again, if you're not sure why that happens, again, that's fractions, that's multiplying, adding, subtracting fractions. Have a look at that note and look that up, practice it, because as you can see, we'll need it. All right, moving on. Now, if that's the case, it is also the fact that this is true. It's that denominator there, it just becomes a multiply by that there. So that xy has come down here, and I can rewrite that, and it is an algebraic fact that is true. Again, fraction stuff. Yeah. All right. Okay. Let's see. Now we can see that y minus x is very similar to x minus y. We can't cancel anything out yet, but we can see that it's quite similar. But just the signs are flipped over. Remember, keep your eyes on the goal. That's what we wanna make. We want that minus one there. So maybe we can factorize out a minus one. So if we're flipping the signs on it, but we're saying it's the minus one times of this, which is x minus y now, because the signs are flipped, right? So this means that we're gonna minus one times that, which gives us the opposite version, which is exactly this. So this is fine. This is good. Actually, it's exactly what we need to do. Now we have these two brackets that are the same, and they are common factors where we can cancel them out. What we're doing is, of course, we're dividing by x minus y, both sides. So they both disappear, leaving us with our answer. which is the right-hand side. So we've proved it. It is indeed the case that algebraically this thing, the left-hand side, is exactly the same as this thing, the right-hand side. Cool. Moving on. 490. The length of the sides of a right angle triangle are 3 consecutive even numbers. Right? Okay. Yep. Yeah. So we know this one. This length here has to be the longest one. It's the hypotenuse. So I'm guessing that's the largest of the 3 consecutive numbers. Find the length of the 3 sides. Remember what I said? Oh, actually, you might not remember. It's not this video, but I have said that. Okay, if you want an arbitrary even number, this is what we say. Of course, you can choose a different letter for it, but we say it's 2 times something, some whole number, including 0, of course. Because even numbers, you should be able to divide it by 2. Cool. So we're saying, let's say that's ABC. And we say that's the biggest one. Which one of these? That one doesn't really matter, to be honest. And plus, we don't need to know. We just need to know the length of the 3 sides. The order isn't too important for us. We just need to know what they might be. Cool. So instead of saying ABC, we're going to call these, let's say 2x. That'll be the shortest one. The next number would be 2x plus 2, because it's the next even number. Not straight consecutive. It is the next even number. And of course, the longest one would be 2x plus 4. Cool. Now, we do know an equation regarding this, regarding right angle triangles and the length of their 3 sides. It's Pythagoras. So we know that that squared plus that squared equals this squared. I'll write that up. No, actually, no, I've written it down just moments ago, actually, didn't I? Or like a couple of questions ago. It's a squared plus b squared equals c squared. And that's Pythagoras. That's Pythagoras' theorem. So let's see if that solves it for us. So we know that the 2 shorter sides. Remember to put the bracket in. Put the bracket in. Because if you don't, you're squaring only one part of it, which is not true. It's that entire number that we are squaring. Cool, let's square it all. That's 4x squared. This is 4x squared plus 8x plus 4. This one is 4x squared. 16x plus 16. All right, and then because it's a quadratic, we will move it all to one side and try to simplify it. We'll move it all to the left, just because that would give me a positive x squared. If you do move it to the other side and you end up with something x squared or whatever number here, or whatever, it doesn't matter, but it's negative, and you don't want it, you can just times everything by a -1, just to flip the sign. But since we can avoid it beforehand, let's do that. Let's avoid it. Okay, there we go. So hopefully I've gotten that right. Seems like I can simplify that even better. I can divide both sides by 4. Let's make it easier for ourselves. I can divide both sides of the equal sign by 4. This side, it is by, boop, 0 divided by 4 is 0. We factorize. We want 2 numbers that add to -2 and multiply to -3. So I think that's this kind of business. Boom. So we're saying x is going to be either 3 or x is going to be -1. We know it's not this case because we're saying that the length of the triangle, are going to be negative. It's going to be a negative length. We don't want negative lengths in our triangle. Yeah, so we're going to say this is the one, this is not the one. So the three sides the three sides are. Remember, 3 is not the length of a side. It's not 3, 4, 5. Remember how, oops, I'll use a highlighter. These are our 3 numbers. And we just found out what x would be. So we're saying the 3 numbers should be 6, 8, 10. Oh, and centimeters, right. They actually gave us the units, so we will use the units. There we go. And out of here. 491. Solve, Bob, when x is a whole number. Cool. All right, let's solve it. Mind you, we have x in the exponents now, as an exponent. So we want to rewrite everything with the same base. So this one has the base of 2. Let's see if we can rewrite everything else as a base of 2 as well. So let's rewrite that. I know we can already see a problem here. We can't really do 60 as a some 2 to the power or something, but we'll get to that later. Let's see. 8 I can rewrite as 2 to the power 3 times 2x minus 2 equals 60. This actually becomes x minus, that's not times there, plus 3. I can rewrite it like that. You can rewrite it like that, which of course becomes 1, x plus 1. All right. Now remember, x is a whole number when x is only a whole number. So doing powers of 2 is not that hard. So if you think about it, 2 to the power of 1 is 2. 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. And we can actually just work this through, and we easily cross over 60 here. So this is to the, when it's, whoopsie-daisy. Right, we know that's the case. So if we want this left-hand side to be bigger than 60, we know that this needs to be 6. It can't be 5. Remember, it has to be a whole number. X is only a whole number. So it can't be 5 because that drops it down to 32. So we know that it has to be 6. So we're saying x plus 1, with just that exponent there, x plus 1 has to be bigger than 6. Okay? Right. So for x plus 1 to be bigger than 6, x has to be bigger than 5. Right? So 5 and also bigger than that. Actually, let's put the equal sign there. Equal to or bigger. So 5 works, and also everything higher works. So not just 5 alone. We're not solving an exact one. We're solving an inequality. So we're saying x equals 5 works, and x equals anything larger than 5 also works. Okay, cool. Find the value of where this. Okay, cool. Lucky for us, it's already in the base of 4. Both sides. It makes it quite easy for us. The nature of these numbers with exponents, we know that for this to be true, we know that has to be true, right? We're ignoring the base and we're just working with the exponents. The exponent of this number, because the base is the same, the exponent of this number has to be larger than the exponent in this number, which is the x, for this whole thing to be larger. Cool. Which is why we get this. So we're losing and we're skipping the 4. Cool. Looks like a quadratic. Now be careful that we're aware that this is an inequality. So we do not put an equal sign there. we're very careful about that. Cool. Two numbers that add to -1, but times to -6, which is that. Remember, greater than 0. When these brackets are both negative, we get a positive number. It's greater than 0. So that's the case when x is less than, right? To make them both negative, right? Less than 2. Okay. No, sorry. -2. If it's less than -2, both those numbers, both these brackets are negative. So we get a positive number there. So that's one solution. Right, remember the parabola will cross at, what am I saying? 3? Yep. And we're also saying that x, when it is larger than 3, it'll also be positive here. So, right? In between -2 and 3, and there's also a 0 in there somewhere, right? It's negative. But when it's lower than -2 or it's higher than 3, we're in the positives. Okay, so yes, I've done, sorry, I've done such a poor job of explaining that, jumbling my words there. All right, moving on. Ask me about this. If that explanation made no sense, and it might not have, ask me about it. I'll walk through the steps of that again. But just for the sake of this video, I'm just going to move on. 493. The area of a rectangle can be represented by blah. State the length and width of the rectangle. Okay, so the area must be length times width, right? So we're hoping to get two numbers that are multiplying to each other. In this case, it's a bit more complicated. So we know the case in which two numbers are multiplying to each other in a quadratic. It's when we factorize it. So let's factorize it, right? So we want two numbers that add to 1, that's from here, but multiply to -21. No, sorry, not -21. 2 times -21, which is -42. Right? Yeah. So, two numbers that multiply to -42, but add up to a +1. That is a 6 and a 7. Or it's a -6 and a 7. So rewriting that plus x in the middle as that. Boom, boom. Factorize. Oops, sorry. Factorize again. Cool. And we can say length is one of, it doesn't really matter which one's which, right? It's a rectangle. That's just an orientation kind of thing, whichever way you look at it. And that's the width. Or the other way around, but that doesn't matter. There you have it. Given the quadratic expression represents the area of a rectangle, what are the possible values of x? Again, we're thinking about a positive quadratic, right? Because this is a positive quadratic. So thinking about that, let's find out where they cross, when it hits 0. So because length is x minus 3, we're saying x is 0. The whole area becomes 0 at, using that one, 3. If you use this one, we also know that it will also, when x is negative 7 over 2, negative 3.5, I guess. That's right there. Negative 3.5. That's a 3. That happens to the area. Cool. So we're saying not all of these answers, this whole sort of range that we have here, this whole range of possibilities for our x values and our area values, they're not all possible. First of all, we're not going to have a negative area rectangle. So we know that everything between 3 and negative 3.5, that bit here, the area is negative here. So we know that's not possible. So we know that's not going to be, that is not a possible value of x. All right, cool. Also, it is not going to be a possible value. It's not going to be a realistic or even a possible rectangle if one of the length or the width is negative. We're not going to have a negative length or a negative width, either one. So we know we can't go over to the left. So we're only talking about when x is larger than 3. So what are the possible values of x? X is larger than 3. Justify your answer. Let's see, negative 3.5, wait, greater than that, but smaller than 3. Area is negative. Also, length and width is negative. Let's say or. Length and width is negative below, what is it? Below 3. So, yeah. To be honest, maybe this one alone justifies it all. Anything below that 3 here, one of them becomes a negative number. So doesn't make sense. So there we have it. Cool. And that's the second page of that. I think I've done a poor job of explaining this sometimes. So I totally understand if you have questions. Ask me, can you talk about that number? What did you do? Anytime. But again, you try it, you make sense of it. As you can see, quite a few of the times in these questions, it is not just a rule that we have in getting to the answer. Sometimes you have to make reasonable assumptions. So that's your problem solving skills. You have to go back to see what is it they're asking you for and seeing if you have the information to solve it, right? So again, try it, and try it. And let me know any questions you have, right? All right, take care.